Okay, so in this class I want to look at some problem solving with simple harmonic motion. Um, and remember all our definitions for simple harmonic motion. I've just put a question straight up here. It's taken from our textbook. It says a particle is moving with simple harmonic motion, and it has speed 6 meters per second and 8 meters per second when its distances from the center of oscillation are 4 meters and 3 meters respectively. I want to find A, the amplitude, T, the period of motion, V bar, the average velocity. Bar always means average. V max, the maximum velocity, A max. And we have kind of formulas that are going to help us solve all this stuff. Okay, so the first thing I'm going to look at is A. So we're given V is equal to 6. When its distance from the center is 4, and V is equal to 8 when its distance from the center is 3. So we know that V is equal to 6 when S is equal to 4. And we know from our formulas that we derived, which are on page 54 of your formula and tables booklet, that V squared is equal to omega squared times A squared minus S squared. That's on page 54 of your tables. Make sure you can find it. So I'm just going to substitute in here. And so V squared, that's going to be 36 if V is 6, is equal to omega squared. Well, I've no idea what that is. Times A squared, I can't really say what that is, yes. And S squared, well, we know that S is 4 in this case, so minus 16. So why this? Well, we know it's moving with simple harmonic motion. We've proven that if an object's moving with simple harmonic motion, then the square of its velocity can be written with this. So we can substitute in our values here and come up with an equation. Notice there are two unknowns here. I'm just going to call that equation 1, and I'm going to keep it to the side for the moment. The second piece of information here is that V is equal to 8 when S is equal to 3. And we know that V squared is equal to omega squared times A squared minus S squared. Substituting in there, V squared, when V is 8, that's going to be 64. That's equal to omega squared, I have no idea what that is yet, times A squared. Again, I don't know what the amplitude is. But I do know that S squared, when S is 3, S squared is going to be 9. There's equation 2. And from here I'm going to use the division property of equations, which says if both sides of an equation are divided by the same number, then the two sides remain equal. So if both sides of an equation are divided by equal quantities, then the two sides remain equal. So I'm going to take equation, it doesn't really matter what I do, I'll take equation 1 and I'm going to divide it by equation 2 essentially. So I'm going to get 36 over 64 must equal to omega squared A squared minus 16 over omega squared times A squared minus 9. Just using the division property of equations, which you've seen, a million times. Okay, this fraction here, 36 over 64, well, 4 is a common factor there, top and bottom. That's going to reduce to 9/16. And that's going to equal, well, the omega squareds are going to cancel here, so I'm going to get A squared minus 16 over A squared minus 9. And now, from here on in, it's just a really straightforward equation. I'm going to use another property of equations called the cross products property, which says if two single fractions are equal, then their cross products are equal. 9 times A squared minus 9 will give me 9 A squared minus 81 is going to be equal to 16 times A squared minus 16 squared, I think is 256. Yeah. Okay, and then from here on in, it's just solving the equation. Subtract 9A squared from both sides will give me a 7A squared over here. Add 256 on both sides. That'll give me 175 over this side. And then dividing by 7 on both sides. will give me a squared equals 25. So that'll tell me a is equal to 5. Okay, a is equal to 5. So we found the amplitude a is equal to 5. Again, we might just find omega here, take either equation. Let's take the first equation. We know that 36 is equal to omega squared. In fact, let me put in a therefore instead here. So from this first equation, 36 is equal to omega squared times a squared minus 16. Well, a squared is 25, so 25 minus 16. And then solving that equation there, 25 minus 16, well, that's 9. 36 is equal to 9 omega squared. Omega squared has to be 4, which of course means omega must be plus or minus 2. I'm just going to say 2. Okay. So that's omega and a. So we know a is equal to 5. And we know that omega is equal to 2. Plus or minus 2, in fact, but we'll just go with the 2. We know the period is always 2 pi over the absolute value of omega. Again, we've derived that before. So that's 2 pi over 2, which is just pi. Okay? So 2 pi. The next thing is the average speed. I want to find the average speed here. I'm thinking about the average speed. Let's think about the amplitude first. We said the amplitude was 5. That means we're talking about something that's traveling around a center point and going 5 meters up, 5 meters down. And it takes pi seconds to complete one full period. So we can work out that average speed is equal to distance traveled divided by time. So what is the distance traveled? Well, to complete one full period, I'm going to go up. That's 5. All the way back down, right down to negative 5. That's 15 units. And then back to the center. That's 20 units in one full period. And divided by the amount of time, that's going to be, we've said, it takes pi seconds to complete one full period. Okay, so it's going to be 20 over pi is going to be my average velocity. That's going to be meters per second. The maximum velocity, again, we came up with an expression for that before. Maximum velocity is equal to omega times a. We said omega was 2, a was 5, so that's going to be 10. Maximum acceleration, we said, was omega squared times a. Omega is 2, 2 squared is 4, a is 5, 4, 5 is 20. Don't forget your units, meters per second squared. Okay, so really useful to know all those different formulas to be able to solve some problems based around simple harmonic motion. Okay, a bit of basic algebra in here as well. So practice some problems from this section, and I'll look at another problem solving lesson, question in my next lesson.